Talking about Transformers Meet Act R, repeat aware and sequential listening session recommendations. Let's give a warm round of applause. All right.
Yeah. Hello, everyone. My name is Viet-Anh, coming from Deezer, a music streaming service. Today, I would like to present you how we leverage real listening behavior to improve the recommendation. So we start with the context why we do this work. Then we formalize the problem that we want to solve. Section 3, we focus on our approach based on the psychology-informed framework called ACTR. We validate our model in the section 4, and finally, we conclude with several main takeaways. Okay, first, repeat behaviors are ubiquitous and important for music. Each time when users connect to the Deezer, they usually listen to re-listen to their favorite songs, as well as to explore new music landscapes with new release songs. That's important for our recommendation to answer two questions. First, how to have the right proportion of repetition and exploration in recommendation. And the second is that how to have the right songs in each part to recommend to users. Well, there are several works in the literature that could help us answer these questions. However, we found that some of them tends to recommend favorite tracks, and some of them, on the other hand, recommend exploration tracks. And this work tried to answer these questions based on the psychology-informed framework. We formalize our problem as the next basket's recommendations. That means each time when users connect to our service, they usually listen to a set of songs within a specific time frame, and we call in this work as a session. And the user listening history is organized as a sequence of sessions. And our recommender system take into as input the user sequence of sessions and try to accurately predict which songs that user will listen to in the next session. It's important to note that it could be the song they already listened to in the past, as well as the songs that totally new for them. And we observe that although that basket or session in this work is really important, it's crucial input for the system, but previous next basket recommendations do not pay enough attention to this crucial component, and especially in the music domain. Most methods use simple item aggregation like average and max pooling, and through these operations, important information on baskets is lost, notably repetitive patterns that is really important for the music streaming. And we first make several hypotheses. First, songs in the sections are not equally important. And the second is that this importance of songs could have a link with the current user cognitive processes. And based on that hypothesis, we propose to use a tensor mechanism to aggregate the song embeddings to build the session representation. And these attention weights are derived from ACTR framework that I will present next. So the adaptive control of thought rational, or ACTR for thought, is developed by Anderson at CMU. It's a cognitive architecture that focusing on memory process that try to simulate human cognition. There are three main modules in this module acting together, the declarative memory, the procedural memory, and the working memory. But in this work, we just focus on the declarative module, which contains the activation equation of human memory. We focus on three components: the base level component, the spreading component, and the partial matching component. The base level increases with the frequency and the recency of the occurrences of the song within the listening sessions. That means that songs that are played often and recently with the user will carry more weights. The spreading component favors songs that are co-listened together in the same section. For example, if we have a song V frequently appears in the section with certain other songs, then the presence of these songs in the current section will enhance the memory activation of the song V. And the partial matching component enables the activation of similar songs based on their musical characteristics. That is a complementary information written to the spreading component. And finally, the activation equations of human memory is just a linear combination of these three components, where the parameters are learned by one layer feed-forward in this work. And the activation WV here is used as an attention weight for the song to derive the section embedding. That is the first and the most important component of the system of this work, that try to extract the section embedding based on the ACTR activation. Based on that component, the first module is the short-term representation that try to capture the sequence dynamic of user behavior. And in this work, we use a transformer with two self-attention blocks. And besides that, we have a long-term representation that try to capture the intrinsic user preference that independent of the context. And for that, we use another attention-based aggregations from the favorite track, where the attention weights are calculated from the base level of these songs. And finally, the user embedding will be the combination of these two representations. To optimize our model, we try to optimize the loss function that is the combination of two levels. The first level is the section level loss, ensure the user embedding being close to the next section representation, while the songs level loss ensures user embedding being closer to the vector of the songs listened to by the user in the next section, comparing with the songs they did not listen to, or we can say that the negative songs. And to validate our models, we use two music domain datasets. The public one is the NFM1B with 1 billion listening history, and another private one with 7 million listening events that will be released with this, within this work. And after several pre-processing process, we have two data sets at the end with repetition rates in the test set is 72 for Last.fm and 89 for Deezer dataset. And we compare our model with two groups of models, the non-repeat aware model, which do not take into account the repeat consumption, and the repeat aware group, which take into account this type of consumption into the model. And our models belongs to this group, where we have two versions depending on which negative sampling strategies that we use. The PISA U that use uniform negative sampling, while the PISA P use the probability-based negative sampling. And we evaluate the quality of recommendations in three aspects. The first one is the accuracy with the NDCG and recall metric. We go deeper with, to see how recommendations work in each type of consumption, the repetition and explore. And besides that, we also calculate the consumption bias based on the average proportion of repeated songs in each recommended list. And this metric shows us whether the recommendation leans toward the repetition or the exploration. And finally, we also calculate the popularity bias based on the median rank of recommended songs. And we first quick check our hypothesis on the importance of songs on the CTR by evaluating the recommendation based on the dot product between the last section embeddings and song embedding. And the last section embeddings is calculated based on the ACTR activation or mean average. And the results of that activation ICTR informed session embeddings outperform the one using mean average. We also study the importance of repetition modeling. The experiments show that repeat-aware methods outperform non-repeat-aware ones across most metrics. This is really important because, especially in the music domain, where users frequently re-listening their favorite songs. And compared with other repeat-aware baseline, our model achieved competitive performance in the repetitions part, and especially significantly in the exploration part. That is really interesting result because enhance the explorations could help users discover new music landscape, especially on the vast catalog in the music streaming device. And we postulate that by leveraging the ICTR activation in both session embedding and user embedding, not only have the model capture the repetitive patterns, but also focus on specific songs which effectively represent a user's music taste that could have the exploration. And we also study the role of each component in the ICTR. If we use only the B and base level, it works really well on the repetition, but it works poorly for the exploration parts. And when we include the spreading component, it significantly improves the exploration, while a little bit inferior performance in the repetition comparing with the base level. And the partial matching component, on the other hand, do not bring any extra performance comparing the spreading one. And besides the accuracy, we also measure the repetition bias, where the positive part means that the system, the recommendation leans toward the repetition, while the negative one means that the system favors the exploration. The more the recommendation close the zero line, the more balance between the two model consumptions. And we can see in this figure that the non-repeat-aware approach, the orange one, are biased toward exploration. That means underestimate how often users re-listen to their favorite songs. And some repeat-aware approach, on the other hand, overestimate repetition, while our model achieves better balance between the two modes of consumption. And comparing with other baseline, our model less prone to popularity bias. And here is a Romain takeaways. In this work, we just want to say that re-listening behavior are ubiquitous and really important for music streamings. And the songs in this section are not equally important, and this importance ways could be derived from the ICTR framework. And last but not least, it's really nice to have a recommendation model that aligns well the recommendation with the actual user behaviors in terms of repetition and exploration. That is, thank you very much for your attention.
Thanks for the talk. There's actually quite a few questions on Slido. We probably only have time for one or two. The highest voted question is that you focus on the declarative memory module of Act R, which focuses on what's already known in memory. Do you plan to extend it to the procedural memory module of Act R, focusing on what we can do based on what we know?
Yeah, thank you very much for your question. That is really good question. At the moment, we focus on the declarative one because we follow the other works in the music domain. But in the future, we will extend to other modules, modules too, to see how it can improve the recommendations.
Cool. Because of time, I encourage you to follow up with their questions offline, but let's thank Viet-Anh again for this great talk.
Thank you.